Now let us consider two examples on mirror formula and magnification so that we can understand in depth. Now let us take an example which is already given in textbook. What is that? Here first one, a, a convex mirror used for rear view on an automobile has a radius of curvature 3 meter, radius of curvature 3 meter. If a bus is located located at a distance of 5 meter from this mirror, find the position, nature and size of the image This is the question which is given in textbook. Let us take how to solve this one. Let us understand. Here, first one, a convex mirror used for rear view on an automobile has a radius of curvature 3 meter. What is given there? First radius of curvature is given. So let us write here, given radius of curvature r is equal to 3 meter. It is given. If radius of curvature is given, according to mirror formula, we must know what is focal length. Focal length means from radius of curvature we can get that. What is that focal length? Focal length is nothing but f is equal to r by 2, because half of the radius of curvature is focal length. So because of that, 3 meter by 2, this gives 1.5 meter. Next, what is given here? If a bus is located at a distance of 5 meter from this mirror, means what? This bus means it is object. It is located. Located means always the object is kept on the left side of the mirror, as we know already. So if this is the convex mirror, just you can take here. Here this is here bus means it is at a 5 meter distance from the mirror. To the left only we have to take. So this value we have to take it as object distance and image distance. We already understood. This is object distance, u is equal to how much? 5 meter. How we have to take that value? We have to take it as negative, because object is always placed on the left of that pole of the mirror, or origin we can say, right? Here, next, here this value how we have to take? Here this is radius of curvature. In the radius of curvature will be behind the mirror, as we know already. So here center of curvature, this is principal focus. This will be what? Radius of curvature. Focal length also, it is behind the mirrors, means this will positive value we are taking here, because to the right of that pole it is measured as positive values. So this is plus positive, will keep it 1.5 meter, right? Now coming to here, what is the image distance? We don't know. Let us keep it unknown. Now according to mirror formula, 1 by u plus 1 by v is equal to 1 by f. We know this already. Now what we'll do is, we'll take phi one side, that is image distance, will make it one side. This implies 1 by phi will be equal to 1 by f minus 1 by u. Now in place of 1 by f, we'll substitute the values. 1 by phi is equal to 1 by f means 1 by focal length we have found out here, that is plus 1.5. 1.5 plus 1.5, it is meter. Next, minus here 1 by u, image is minus 5 meter. We have to keep this in the bracket, minus 5 meter. Now after simplification, what happens? Here minus into minus, this becomes plus. So 1 by 15, this what we can make is 1.5 is there. Let us make this as 10 by 15. We can make it. Now minus into minus, it becomes plus. So 1 by 5. Now by taking LCM is just 15 it is. So LCM is 15. So let me write it as 15. 1 by phi is equal to 15. Up 15 ones are 5 threes are, okay. 10 plus 3 is 13, so we are getting 13 here, okay. 13 value is positive, so here this implies phi is equal to 15 by 13, okay. Reciprocal we are taking here. When we divide this, how much do we get here? 15, 13, 13 was a 13, what 2 remains, 0.2, 13 was a 13, 13, what remains, 7 remains, 70, 13 5 13 5 65, 4 5 remains, 1.15 we are getting here. So image distance phi is equal to 1.15 meter, 1.15 meter, where it is behind the mirror. Image is formed 1.515 meter behind the mirror. Behind the mirror, position is behind the mirror. Its distance is 1.15 meter. This is what image distance, what we got now. Then what is the magnification then? Magnification we can show here like this. Magnification is equal to, that is a height, the ratio of height of the image to the height of the object, or else here object and image distance we have. In terms of that we can calculate, that is m is equal to h dash by h, this will be equal to minus phi by u, right? Minus phi, we have to write this minus phi, this is 1.15 divided by u is how much, u we have got already here, that is minus 5. This minus minus gets cancelled, so let us make this as 115 we can make, divided by down 500 we can make, because shifting two places. So when we divide this, how much do we get here? 115, this is 500. So here keeping point, we can take 10, 115, we can take 10 here now. So how much 2s we can take, means 1000, what remains, 150 remains, 150, point is there already, let us take 0, 1500, 5 3s means here it goes completely 1500, so what remains, 0 0 0, okay. So 0.23 we are getting here, that is magnification is positive value, is positive value we are getting 0.23, 0.23, 0.23 means what, the image is smaller. In the convex mirror usually image will be virtual, erect and smaller, right? And here it is a smaller, image is smaller by a factor of 0.23, image is smaller than the object by a factor of 0.23, okay. We can say where is that image formed, behind the mirror it is formed, okay. Virtual and erect, so these are what it is asked, that we can say here. So this is answer for this question. Next we shall take one more question which is given in the textbook, same. Okay, now next example it is given. Next example is what? An object, an object 4 centimeter in height, is placed at a distance of 25 centimeter in front of a concave mirror of a focal length 15 centimeter. At what distance at what distance should the screen be placed in order to obtain a sharp image. This first part. Second part, they ask what is the nature and size. Find the nature and size of the image. This is question, it is given already. Now let us analyze what is given first. Given, if you write here, an object of 4 centimeter in height of the object is given. So height of the object is what? H equal to 4 centimeter, it is given. Is placed at a distance of 25 centimeter in front. Means what? This object distance they have given 25 centimeter. It is what? Object distance 25 centimeter. It is in front of a concave mirror they have to. Let us show this in the diagram form. This is the concave mirror, right? This is the object 25 centimeter distance. Now here you see this is 4 centimeter height. Yeah, right. It is placed in front of a concave mirror of focal length. Focal length of that concave mirror, it is here, this side to the left of the mirror we find, right? So that focal length, say for example, this is f, this is focal length p to f, right? So object distance we have to take it as negative because it is on the left side of the origin. So this is minus 25 means minus 25 centimeter object distance. And next coming to image distance. Here 15 centimeter focal length, let us write that also. Focal length is 15 centimeter. We have to take it as a negative value because it is to the left of the mirror, centimeter. Next, what is asked? Image distance is asked. Phi is equal to what it is asked. Next, size it is asked. Size means magnification is also asked, right? Now coming to here, first one, mirror formula. Coming to mirror formula, say 1 by u plus 1 by phi is equal to 1 by f, right? Now coming to here, we want to what image distance. This implies 1 by phi will be equal to 1 by f minus 1 by u. Now 1 by f is how much here? F minus 15, it is minus 15 centimeter. Here minus 1 by u is what? Minus 25. 1 by minus 25 we have, right? Now after simplification, what we get here? 1 by phi will be equal to here this is 1 by minus 15 minus into minus, this becomes plus 1 by 25. Now after this one taking LCM, 75, 25 3s are 15 5s. Okay, 75 is LCM. We get 15 5s are 25 3s are, right? This is 5 minus 5. Here minus is there, minus 5. Next here 3 plus 3. This gives what? Minus 2 by 75. 1 by phi is equal to minus 2 by 75 we got. So this becomes phi is equal to, this becomes 75 divided by minus 2 it becomes, right? So whatever the value we get, that will be negative. Phi is equal to minus 75 by 2 it becomes. Means what? This becomes 75, 37.5. What? Negative value it is. Minus 37.5. This is what? Image distance. Where it is formed, minus means what? The image is formed in front of the mirror because minus values they are taken to the left of the mirror, right? From the pole. So this is formed in front of the mirror, we find the image. And coming to magnification. If it is in front of the mirror, it is what? Always it is real and inverted. Because from the concave mirror we already studied, if the image is in front of the mirror, if it is coming, that is always it is inverted and real. It is not virtual, right? Next, coming to magnification. Magnification is equal to height of the image divided by height of the object. Here, height of the image, instead of this, we can relate it as minus phi by u, as we already studied. Now, here minus phi by u. Phi means image distance we already found out. That is minus, here inside minus 37.5. We have to take the values as they are. Next, coming to here u. U is what? Minus 25. Minus 25. We have to divide this. So how much do we get? This one, this minus, or minus into minus plus, it becomes down minus. Finally this remains as minus. Okay, so minus, let us make this as 375 divided by 250. 250 for simplification purpose. So 375, 250, when we divide this, how much do we get? 250 once, 250 we get. We cannot take 2 some. Okay, 5 minus 0, 5. 7 minus 2, it is 3 minus 2 is 125. Here we can take here 0.1, 1250 we got. 250 4 means 1000, 5 we can take this as. So 250 to 1 5, if we do 1250, we get exactly 0 0 0 0, right? So 1.5. What is this? 1.5 magnification is 1. Value is minus 1.5. This minus 1.5, it shows, means height of the image is measured below the principal axis. Because of that, we are getting that minus, that is inverted. This minus sign indicates that it is image is inverted, it is real, and it is image is 1.5. Means what? This is image height of the image. Okay, now we see magnification. When we take this, is 1.5 factor larger than the object. Here height of the image is 1.5 factor, it is larger than the height of the object. So magnification we are getting 1.5. So this is how we are getting. And what we found out here, nature, size, and position. Position is in front of the mirror we got. Size is, it is larger than the object. Next, it is real and inverted. These are property of the images what we have got there. So this is what the solution from the problem. Okay. So in the next class we shall study about refraction of light. Okay. Thank you.